Here's an introduction to the law of sines and cosines. So before I really go into their formulas and what's important, I think it's important to understand exactly what types of triangles exist and where you may want to use the law of sines or the law of cosines. It's really the two specific cases which I think are really important are SSS and then SAS. Side angled side. So if you're given all three sides, or if you're given two sides and then there's an angle between those two sides, then you want to use the law of cosines, because it's this formula is usually preferred if you're given more of the sides, right? Now, on the other hand, if there's a triangle that's given and you're given more angles, for instance, AAS or ASA, something like that, right? There's a side between two angles, or there are two angles and then there's just this one side, then you would want to use law of sines, because this is used better if there are more angles given within the triangle. So law of cosines more for sides. If there are sides given, law of sines more for if there are angles given. So that's just for, again, there are other types of cases, but again, these four are the main ones: SSS, SAS, AAS, ASA. One with more angles, use law of sines. One with more sides given, use law of cosines. So now here are the formulas now, and so I will be just stating them here, and then we will be utilizing these formulas later in the later lesson where I go over some specific problems. So the law of cosines, here it is. Law of cosine. So law of cosines, right? Now this states that a squared is equal to b squared plus c squared minus 2bc cosine of A. That's the formula. And really, when I say A here, right, usually labeling this as a capital A indicates that this angle is opposite this side. So you could have something like, I don't know, b squared is equal to a squared plus c squared minus 2ac cosine of this angle here, cosine of b. So really, it doesn't really matter what you call as a, as long as the angle, the cosine of the angle that you take is the angle that's opposite side A here. So the angle that's opposite this side here in the formula should be this angle. So this is just a way of saying that, oh, angle A is opposing, it's relatively, it's the angle that's opposite side A. So this is a formula that you should know for law of cosines, and it's quite interesting because if you look at this, you can derive the Pythagorean theorem, or not even derive, but it just makes sense. You know, for instance, if I have this right-angled triangle, right, for the Pythagorean theorem, and this is 90 degrees, as we know. So if we look at this, right, and our cosine of we're looking at cosine of a particular angle, right? So if we say that obviously this angle here is A, and this is B, and then this is C, right? And we know cosine of 90 degrees, right? Cosine of 90 degrees is 0, right? And then you have minus 2bc here, right? And then you have a squared is equal to b squared plus c squared, right? And you have minus 2bc cosine of, I think I put cosine of 0, I meant cosine of 90 degrees, right? So you have 2bc minus 2bc, cosine of 90 degrees, which I meant is 0. So evaluating cosine of 90 degrees, as we know, that's just somewhere here, right? Cosine of 90 degrees here, and it's the x-coordinate, because this is cosine theta comma sine theta. So that the x-coordinate of this point here would be 0. So if you know your unit circle again, you know that cosine of 90 degrees is 0. And so if that's 0, clearly all of this just goes away. So you're left with a squared is equal to b squared plus c squared, which is really the Pythagorean theorem if you think about it, because a is your hypotenuse. Pythagorean theorem states that b, or one of the legs of your triangle squared plus the square of the other leg, is equal to square of the hypotenuse, or c square. And so that's what this is. B squared plus C squared is equal to A squared. That is the Pythagorean theorem. So law of cosines here indicates why the Pythagorean theorem is also true here. So that's quite interesting. So that's a law of cosines formula for that. And again, it's used primarily when you have more of the sides given. Now when we're looking at law of sines. Law of sines, right? Law of sines is just sine of angle A divided by A. That ratio is equal to sine of angle B divided by side B is equal to sine of angle C divided by side length C. And again, these sides here, A, B, C, these are sides in reference to angles A, B, C, and angle A is opposite side A, angle B is opposite side B, angle C is opposite side C here. So again, when I'm talking about A, for instance, you have a triangle here. If this is A, or if this angle is A, then this side length is lowercase a. If this angle here is B, I would label this as lowercase b. And if this angle is C, then this side length here would be C. So again, that's just the notation that you want to know. But that's what the law of sines states. So again, this formula will be primarily used again dealing with triangles that have given angles. So for law of cosines, it was more if you're given a side. So for you're given more of the angles, then you want to use law of sines. It's just easier that way. So those are the two formulas that you may want to write down. In the later lesson, I will be going over specific problems that deal with these two laws. So thanks for watching.